Good morning. Good morning. Yeah, so there's a problem with the timeline problem. You might not, may or may not be aware of it. Okay, the idea of a timeline problem is that it takes billions of years or light years for light to reach us, or millions, or whatever it is, because light is said to take 186,000 mile second trip. It's said to travel 1 second in 186,000 miles, or well, there's 300 kilometers per second or something. So there's a problem with that because it's a simple problem. Anybody can understand it if you think about it. Is that that's fine as long as your measure of a second and your measure of a mile or a kilometer remains the same. Problem is that it doesn't remain the same, especially if you're a photon. But let's just think of it for a second, even in the what do you call it, the time frame where we're at, the frame of reference where we're at, where we have 186,000 miles and a measure of 1 second. Okay, but we know that distance will change, will vary, and time will vary. They say, oh, it's not very much. But yes, it does vary quite a bit, especially if you're a photon. But let's just say, think of this a minute. So let's just say we go near a black hole and gravity is a lot stronger so that it slows down time. And let's say it shrinks the measure of distance. I've explained this before, but I'm just going through it quick right now. So that means that it will take longer because your second slows down and your distance decreases. That means it'll take longer to travel less distance because your measure just shrunk and your rate of time just slowed down. So it takes longer to travel less distance relative to where we are because our measure of 186,000 miles is bigger or longer or larger than the measure of 186,000 miles near a black hole. And let's go the other way now. Let's say we got away from all these black holes and gravitational wells around the universe, and let's say that time, the rate of a measure of time goes by faster. Okay. And let's say that the measure of distance increases even more than where we're at, our frame of reference here. So let's say 186,000 miles is like say a billion miles or whatever. So that means it takes less time because your second goes by a lot quicker, less time to travel a greater distance because there's no gravity to dilate distance or time as much. So time goes by faster, so your second is shorter. So that means you're going to be traveling, the light is going to be traveling a distance which is greater than 186,000 miles, or say it's a million miles or whatever. So it's traveling a greater distance in less time. So what does that mean for the speed of light relative to where we're at, where we are in our frame of reference? And I'm talking about jumping from one frame of reference to another frame of reference. I'm not talking about within the same frame of reference of the same measure of distance. But if you jump from one, if you compare one frame of reference to another one, that means that the speed of light goes faster where there's less gravity. And it goes slower, light goes slower where there's more gravity. That's what gravitational lensing is, for crying out loud. Okay? So it's a known fact that the speed of light does not travel at the same rate. Okay? So let's extrapolate that further. Let's say we're a photon traveling at the speed of light. Hello, Javier, Ramos, and Carnivorous Ape. How you doing? So let's say we're going at the speed, the rate of the photon. The photon's going at the speed of light, so what does that do to time? Now this is special relativity. This is not general relativity. But you're going at the speed of light, and what does that do for time? It means time is going by real fast. In fact, it'll take no time for the photon to arrive. The photon experiences no time, and it actually travels no distance at the speed of light, because distance goes down to zero, and the time is instantaneous. So that means it takes no time for the photon to travel no distance, so it's already there. As soon as it leaves the star, it's already here. Okay, that's the problem with the time-light problem, is that light arrives instantaneously, and when we go to observe it, it takes time to arrive because we are the ones existing in a fabrication of dilated, quantifiable, limited time and distance, or measurable time and distance. See what Carnivorous Ape says here. Hold on a second. Oh, well, let me see. He says, yeah, that's not how it works. The speed of light slows down when reacting to gravity, but that's covered under special relativity. Special relativity has to do with speed. General relativity has to do with gravity, okay? So that's the way that works. But anyways, the photon doesn't experience any time. It's already there. You know, Jason talks about a one-way speed of light. Well, it's the actual speed that takes, or actual time it takes for a photon to arrive, is no time. And that's what and the scientists should know this too. They're just trying to hide behind our fabrication of dilated time and distance and extrapolate age of the universe from our dilated rate of time and distance, when in fact the photon arrives instantly and takes no time to arrive. And because it's actually traveling no distance, because distance goes down to zero at, at the speed of light. That's the way the math works. So there is no such thing as a light year, because as far as the photon concerned, as soon as it leaves the star, it hits your eye. Because for the photon, there is no distance and there is no passing of time. So they're being real deceptive about this, these light years and millions of years, when there is no such things as millions of years when you're talking about the speed of light. Okay, see if carnivorous ape has a readjustment here. Well, that's just wrong, he says. We know the speed of light, and it's not instantaneous. It's very accurately measurable. Well, when you go to measure it, you're measuring it at your dilated rate of time and distance. You're not measuring the time it takes for a photon to arrive or the distance it's traveling, because it's traveling no distance and it's taking no time. That's a matter of fact. But when you go to measure it, you exist in the fabrication of expanded or dilated time and distance, where things take time to arrive. So when you're talking about gravitational lensing, that's because it's going through a greater distance one place than it is another place, and it causes a gravitational lensing for us when we look at it, because we exist in dilated time and distance. But for the photon, it arrives instantly. That's just how that works. And because remember, everything's relative to your perspective and where you are and what you are. So and the speed of light is not always the same speed anyway. This is what I'm trying to say. This is what I'm trying to point out. Depending on where you are, the speed of light is different, a different rate. But that's not possible. The speed of light can't have two different speeds. It only has one speed, and it's instantaneous. This is what, I mean, I can understand this. I don't know why the scientists can't explain it. You can't have two speeds of light, but you do have two speeds of light, because that's what gravitational lensing is. Gravitational lensing is an effect that happens because there's two different speeds of light, or differing variable speeds of light. But there is no such, there's only a variable speed of light within the fabrication of dilated time and distance. But when you're talking about the photon, there is no varying rate of the speed of light. As soon as it leaves, it's already arrived. It just can't arrive before it leaves. That's why you can't have a speed greater than the speed of light. Because if you do, that means that the photon arrived before it left. And that's not possible. It's really not complicated. So how, tell me this, Carnivorate, how can you have two different speeds of light? How can you have gravitational lensing? That's not possible. It only appears to take time in our dilated time and distance. That's why you have gravitational lensing, because you're talking about two different speeds of light, or a variable speed of light and distance, of course. Because when you're going through a gravitational well, there's more distance in a localized place that it has to travel through. Okay, so we got here. Oh, you, Carnivorate, you want to join? You want to talk? Because this is kind of annoying here. Let me get my earphones. I mean, if you want to join, you can join. But anyways, the speed of light being instantaneous is a ridiculous notion. We can accurately show it takes approximately 8 minutes for the photon to get from the sun to the earth in our frame of reference. In our frame of reference, it takes 8 minutes. But for the photon, it doesn't take any time. He's out of commission for a while. Had a storm come through and a flood. Wow. Out his computer. Okay. Well, I hope you get things back in order. Okay. Things happen sometimes. But yeah, the fact that you have gravitational lensing proves that there's more than one speed of light, because that's what gravitational lensing is. Because either it's traveling a greater distance or it's traveling at a slower rate of time. And it's actually doing both. So when it goes near a gravitational well, it's traveling a greater distance at a slower rate of time. That's why the photon takes longer to reach us in our frame of reference. In our frame of reference. But it's actually arriving instantly. But the way we see it in our frame of reference, it takes time. But it's actually arriving instantly. Scientists know this. They know this. And how can you have two different speeds of light, or a varying rate of speed of light? And I just proved when your speed of light is based on the parameters of distance and time. When distance and time change, which they do change, it's going to affect the speed of light. It's going to affect when or how long it takes for light to arrive according to your frame of reference, in your frame of reference. So if time slows down, it's going to take longer to travel less distance relative to our frame of reference. That's what gravitational lensing is, that it takes time. A photon isn't a thing, or it's not a thinking agent. It doesn't have to think. It doesn't have to think. It has no mass, so it takes no time to arrive. It's not, see, things have mass, keep things from going the speed of light. Anything with mass can't go the speed of light because it'll become infinitely dense And it's just not possible because it'll take too much power for it to travel the speed of light. You can't get it because the faster something goes, the heavier it gets, and the more power it takes to move it, which there is not enough power for that to happen. But with a photon, it's massless. It doesn't take energy for it to arrive. It doesn't take. I mean, it arrives because it's massless. It doesn't take more and more energy to make it go faster and faster, so it arrives instantly because it's massless at the speed of light, which is a phenomena. But yeah, but in reality, as soon as the light leaves the distant galaxy, it hits your eye. It strikes your eye. That's the reality. But when you go to measure it in your dilated fabrication of time and distance, you'll see it, you'll observe it take time to arrive. But the photon exists at the speed of light. It doesn't exist in our fabrication of dilated time and distance. From our frame of reference, it looks like it's taking time to arrive. It looks like it's arriving at different rates of time. That's why it looks like the distant galaxies are closer, because you have a gravitational lensing effect that magnifies distant galaxies. So they look like they're closer, but they're not closer. But they look like they're closer than what they are in our dilated fabrication of time and distance. But that's the way it is that that's the problem with the time light problem, is that the light is reaching us instantaneously and we are seeing it take time to arrive. That's our experience in a fabrication of dilated time and distance as a result of gravity, which gives us the ability to see the stars and the gravitational lensing, which is light traveling at different speeds. But light doesn't travel at different speeds. That's what the problem is. You can't have the speed of light traveling at, or different speeds, or even stopping, because in black holes, the light stops. And that's because of our dilated fabrication of distance and time. But light is not traveling at different speeds. It travels at one speed, and it arrives instantly, because it takes no time to travel, no distance for a photon, because it's massless, because it's traveling at the speed of light, which is the fastest possible speed that it can go, which is instantaneously. It can't arrive before it left. There's only one speed for a photon to travel, and that's instantaneously. So you're saying that a photon from Alpha Proxima gets to us instantly even though science says it takes 4+ years to get here. How are you coming to this conclusion? Yeah, it takes time. When we go to observe it, it appears to take time. Yes, but it's not actually taking time. From our perspective, where we are in dilated time and distance, the fabrication of dilated time and distance, it appears to take time. But the photon does not exist in a fabrication of dilated time and distance because it exists at the speed of light, which for it is instantaneous. But for us, it looks old, but we can see everything because of the fact that light arrives instantly. But it looks like it's taking time to arrive to us. It looks like light is taking different rates of time to reach us, and that's what gravitational lensing is. But in reality, the photon arrives instantly. So it's like when you do spearfishing and you're at an angle, it looks like the fish is in one place, but he's not in the place that it looks like he is. He's in a different place. So that when you throw the spear at the fish, you have to throw it below the fish, underneath the fish. You can't throw the spear at the fish, because if you throw the spear at the fish, you're going to miss the fish, because he's not where he appears to you to be. The reality is that the fish is in a different location than what you see him to be. And it's the same thing with this speed of light, because it's the bending. We're talking about the bending of light, and that's how we can see things, is because we exist in the fabrication of dilated time and distance, because we have mass, where things take time to occur. But with a photon, things don't take time to occur. They happen. It exists at the speed of light, which is instantaneous. And it's the same thing with electrons that are moving almost the speed of light. They worry about where the electron is, but in reality, the electron is in every place all the time, because it's existing near the speed of light. So it's basically almost everywhere all the time. But when you go to measure it, you'll stop it in its motion, and you'll find it in one place or another, and there's a probability of where you're going to find it. But as far as we are concerned, it's virtually everywhere all the time. But anyways, this is the problem with the time-light problem. It has a problem, because you can't have light taking different amounts of time to arrive when it arrives instantly. You can't have light traveling at different rates of speed. And if you change the measure of distance and you change the rate of time, you're changing the speed of light. This is what I'm talking about. And this is the reality, is that in the fabrication of dilated time and distance, you're going to have a second that is slower and a distance that is smaller. It's the same measure of distance that's here, is one size here and it's smaller somewhere else. But that's because of gravity. But so that's why we see it take longer to arrive. But in reality, it's arriving instantaneously. I mean, as far as the photon is concerned. But the problem is that the photon is going at one speed. It's the speed of light, which is instantaneously for the photon. Okay, so we have one speed of light, and yet we have gravitational lensing, which means that there is a variable speed of light. Now, which is it? Is it traveling at different rates of speed, or is it traveling at one rate of speed? My suggestion is traveling at one rate of speed, but our observation of it is variable. Because you can't you can't have light traveling at different rates of speed. But what we observe is that it does travel different rates of speed. It changes the speed of light. When you change the parameters of distance and time, you're changing the speed of light. That's what the problem is. Okay, this time light problem, as I understand it, is that the universe is only 6 to 10,000 years old. Then why are we see stars that are billions of light years away? Only a problem with young Earth creation. Well, that's what I'm saying. It's not a problem for a young Earth if the photon is arriving instantly. And it is arriving instantly. Except for our dilated fabrication of time and distance. It's the gravity from the mass of the matter that makes it appear for light to take time to arrive. And that's why we see light traveling at different speeds. When in reality, there's only one speed that light travels. Light can't travel different speeds. But it appears to us in dilated time and distance that it is traveling different speeds. That's what gravitational lensing is. It appears like it's taking time when it's arriving instantly. It's actually arriving instantly, but appears to us as if it's taking time to arrive because of our dilated time and distance. So it's not a problem for young Earth creation because it's arriving instantly. It's just that time is a fabrication. There is no absolute measure of time and distance. Time is something that is fabricated. It's made. It's something that appears to be. It appears like light is arriving at different rates of speed. It appears to us because we are in the fabrication of dilated time and distance. So time itself is a fabrication. That's what the problem is. Our dilated fabrication of time and distance, where we see light traveling at different speeds is a fabrication. It's the result of dilated time and distance in the universe, because there is no single rate of time or distance in the universe. So if there's no single rate of time or distance in the universe, you can't put an age on the universe. Can you understand that? So what rate of time are you going by to put an age on the universe? When time itself is a fabrication, the result of the formation of matter that has mass that dilates time, that makes time and distance. Okay, instantly according to scientists. Yet it arrives instantly according to the photon. As far as the photon is concerned, it arrives instantly. That's not gravitational lensing. Gravitational lensing is a distortion effect, the location of a celestial body, not its distance from us. Well, that's what I'm talking about. It's a distortion. It's not the reality. Because the reality is that light, there's only one speed of light. But the distortion is that there are many speeds of light, many different rates of time, many different measures of distance. But that's the dilation from the matter in the universe, from the mass of the matter in the universe, that is distorting the perception, so that we see light traveling at different rates of time. We don't actually see the fish in the right place. We don't see um, the galaxies. I mean, the galaxies aren't as close as what they appear to be by way of gravitational lensing. They're farther away than what they appear to us to be. And it's all because of the dilation of time and distance, but it's because time and distance is a fabrication. And you can't put a date or age on when matter in the universe was made to exist. So when matter in the universe was made to exist, that's when the fabrication and dilation of time and distance began to happen, after the formation of matter, which dilates time and distance, which makes things with mass to be able to occur. I mean, physical, makes possible physical things to function, because of the fact that time and distance is dilated or quantifiable or measurable or limited, where things can occur, where things can happen, because you have time and you have distance. Because without matter, you're not going to have dilated time or distance. So the question is, when was the matter made, not how old the universe appears to be. Sure, it appears to be millions of years old, but what we are seeing is not the reality, because light actually arrives instantly. But it appears to us to be millions of years old because of the dilation of time and distance, because of the fabrication of time and distance. But you can't tell, since there's no absolute measure of time or distance in the universe, you can't know when time and distance was made to exist. because the age of the universe is different depending on where you are in the universe. You know, there's places in the universe where time goes by real slow, and there's other places where time goes by real fast. There's no single rate of time or distance in the universe. It's all a fabrication. The fish appears to be in one place when he's in another. The distant galaxy appears to be closer when it's farther away. Things are not what they appear to be because of the dilation of time and distance. Light actually arrives instantly, and it appears to take different rates of time to arrive. That's what gravitational lensing is. And you can't have light traveling at different speeds. Did you get a hold of some bad mushroom? No, see, now you're changing the subject. You're not talking about what the subject is. You're not talking about how you can have different rates of speed for the same photon. You can't have different rates of speed for the same photon. It's going at one speed, and that's instantaneously, and it appears to take time, which gives the appearance of millions of years if you go to add it up. But it's all a fabrication. There's not a single scientist that would agree with you on the speed of light thing. No, they admit as much. They admit as much. They talk about gravitational lensing all the time. So they're saying, when they say they can see distant galaxies that appear closer than what they really are, they're admitting that that they're seeing the same photon or travel at different speeds. Well, they're actually different photons, but they're traveling at different rates of speed. Wildheart, what's up? You should know by now, Carnivorous Ape. JJ is always right. He has the truth. See that? Yeah, the scientists know that for the photon, as far as the photon is concerned, it takes no time to travel no distance, because that's what the speed of light is. In special relativity, there is no distance at the speed of light, and it takes no time. Takes no time to travel no distance. It's already there. Scientists know this. Scientists also know that you have the same photon or the same kind of photon traveling at the same rate of speed appears to arrive at different times, causing gravitational lensing. That's what that's what a lens effect is that one photon is being slowed down to arrive later than another photon. They talk about gravitational lensing as a tool to see around black holes or massive bodies. Gravitational lensing says nothing about the speed of light being instantaneous. Again, gravitational lensing is, you're talking about the speed of light, the speed of a photon, which is the same, but gravitational lensing means that they're arriving at different rates of time, or they're traveling at different rates of time. And all photons travel at the same speed, but they're arriving at different times, meaning they're traveling at different speeds. And they're not traveling at different speeds. That's what the point is. They're not traveling at different speeds, but they appear to us to be traveling at different speeds. That's why we can see distant galaxies by way of gravitational lensing, because the photons appear to us to be traveling at different speeds, and it puts the distant galaxies in a different place than what it really is. Just like when you look at a fish in water, the fish is not where it appears to be because of the bending of light, which is the result of the different rates of speed of light. Because light is a lens will slow down light to make it travel different speeds in our time and distance. Well, a lens actually does slow down the speed for us, because it goes slower through water, it goes slower through glass. So that's what the lens effect is. But in outer space, it's the dilated time and distance itself that is slowing down the light, or appears to slow down the light to us, when in reality the photon is traveling at one speed, not different rates of speed. They travel at the same speed, they get to us at different times because they're different distances from us. No, no, the light from the distant galaxies, they're all leaving at the same time, and they're supposed to be arriving at the same time, but because they're going through dilated time and distance, is that they appear to us to be traveling at different speeds, placing the galaxy in a place where it really isn't. So we're seeing things in one place when it's really in another place. Shalom, Jesus is Lord. Just like you see the fish in one place and it's really in another place. So if you want to hit the fish with a spear, you have to shoot underneath it to try to hope to hit it, because he's not where he appears to be. The reality is that the fish is in one place and he appears to be in another place. It's the same thing with the galaxy. It appears to be in one place when it's really in another place. They're different. They're different from, yeah, but they are from different galaxies. So different distances translate for me, carnivorous ape. No, but you're talking about light from the same galaxy is basically the same photons are leaving at the same time. Still up. I just woke up, actually. So, but the thing is that the what you're seeing is not the reality. The millions of years that you're seeing is not the reality, because time itself is a fabrication. That is demonstrably wrong. A photon leaving the sun will get here in about 8 minutes, but one leaving Alpha Proxima at the same time takes over 4 years, and that's our next closest star. From your perception, it takes time to arrive because of the dilation of time and distance, but not in reality. Then they would get to us at the same time. Yeah, they would, or they do, but they just appear to us to arrive at different or to travel at different speeds. But in reality, the photon is not traveling at different speeds. It's that it's going through dilated time and distance. Hey, I just woke up. So according to the photon, it arrives instantly. But according to our perception, we don't see things the way they really are. We're seeing things through the fabrication of time and distance. And it's not what the reality is. It's a fabrication. The distant galaxy is not as close as what it appears to be in reality. So what we are seeing is not what the reality is. The reality is that light arrives instantly. You're laying in a hammock. Are you laying in a hammock out in the woods, or do you have a shelter? Or are you flooded out? What's the deal? Don't forget to put the rest of your body to bed too. I just woke up. Get your attitude going live on YouTube to bed. I just woke up. Oh, I must be seeing the post, delayed post or something. Just got back from camping. I've got one in my yard. I got one in my yard because my room flooded. Yeah, that's what I was wondering. Um, yeah, so what we are seeing is not the reality. We're seeing light through a lens. We're seeing the universe through a lens. And it's through dilated time that we're seeing the universe. We're not actually seeing actual times, because time is a fabrication that's runs at different rates. So we're not actually even seeing the actual time. The actual time is instantaneous, but we don't exist at the speed of light. We exist in a fabrication or dilation of time and distance. So we see the universe through the lens of the dilated time and distance, which appears to be millions of years old, which it's not. Okay. You're not too old for spanking, JJ, from Javier, obviously. Yeah. See, need to replace my computer, but most everything else survived. I have to shampoo the carpet in the morning because everything smells like, well, that's messed up. It's not good. Speed of light is not instantaneous. JJ, that's where you are going wrong. According to the photon, it is, but we're looking at the speed of light through the lens of dilated time and distance. That's what the problem is. Because light does not travel at different rates of time or different speeds, unless it's going through glass or water. But in a vacuum, it's not traveling through or different rates of speed. But we're seeing light through the lens of dilated time and distance. It's sad that a 16-year-old is telling you to go to bed, aka me. I just woke up. I just got up. Just now. This is morning for me. Of course, it changes all the time, but right now it's morning for me. Because I just got up. That's what I'm trying to explain. So, so is the fish really where it appears to be? No, the fish is in another place, not where it appears to be. Is the galaxy where it appears to be? No, it's in a different place from where it appears to be. So we're seeing the universe through the lens of dilated time and distance, which is not, it does not have the age that it appears to have. Go dream about something. But the important part is how fast the photon is going relative to us. Doesn't matter if the journey is instantaneous to the photon. Wow, Wild Heart's getting brainy here, getting smart. Yeah, in through going through our dilated fabrication of time and distance, yes, it does run at different rates and different time because of the dilation of time and distance. So that's what makes it look to be millions of years old when it's not. Because we are not seeing the reality, we are um, seeing it through the dilation of time and distance, which is not the reality. Don't care about evolution versus creation stuff. I'm telling you to go to bed. Javier, come on. I just woke up trying to explain. Again, I basically said what Carnivore Ape said, but a lot worse. And science stuff too. Oh, that's okay. Yeah, but you have to admit that you're not, what you're seeing is not the reality. That's the whole point. Because light does not travel at different speeds. It does not, it travels at one speed, which is the speed of light, which for as far as the photon is concerned, as soon as it leaves, it hits your eye. But then when you go to measure it or look through the fabrication of time and distance, it appears to take time to arrive, different rates of time to arrive. It appears that the speed of light is traveling at different rates because it's going through dilated time and distance. That's why it appears the speed of light has different rates of speed. That's why there is gravitational lensing, because it's going through the dilation of time and distance. Okay. He just got up, Javier. Billions of years old, not millions. Yeah, it's not billions of years old. It appears to be billions of years old because you're looking at the universe through dilated time and distance. I don't care that you got up. I'm telling you to go to bed. I got stuff I got to do. I don't care. It's our reality. The photon has a different perception of reality. It's our reality. No, it's our perception of reality. Fair enough. I can't really argue with that, Javier. Are you telling who you telling to go to bed? Wildheart or me? I thought you were telling me to go to bed. But anyways, you have to understand that the fish is not where it appears to be. The galaxy is not where it appears to be. In fact, sometimes you'll see multiple kaleidoscope of galaxies when it's all the same galaxy, all in different places. And you know that's not where it is. You know that's not the reality. Okay? So you're actually seeing what is not the reality. That's what I'm trying to explain to you. You are not seeing what the reality is. If you're seeing a kaleidoscopes of the same galaxy, you're not seeing what the reality is. Okay? It's not complicated.